So welcome. So in this lecture, I'm going to go through a few derivatives. Some of these you may already know and some you don't. And I'm going to go through them with pictures, but these are ones that are useful. Particularly cosine and sine, I'm not sure that you dealt with in the fall, but they're so useful and simple that I'm going to go through them now so that we can use them as examples when we get to integration. So I'm a very visual person. You find that throughout the course. So I'm going to draw always pictures of what's going on also. So let's go ahead and do that. So I'm going to start with the function that's going to be, the first function I want to look at is f of x equals e to the x. And let me get our axes here. So let's draw this. And the way that this graph of this function goes is it's going to go, as we put in really big negative numbers, this ends up looking like 1 over something really big, and so it gets really small here close to the axis. And then it's going to go through 1 and then up really fast. This is exponential growth. This should be one of your, if you're in business, this should be one of the most important functions for you to understand. You should understand how exponential growth works better than almost anything. Okay, so this is what the function looks like. And then the derivative of this, right? So if I take the derivative with respect to x, I like to write the derivative with respect to x like that, then I'm going to have, and I'm going to take it of the function e to the x, I'm going to get e to the x. So this is also something that makes this kind of a fun function. It's the only function you can do that with. And then what does that kind of correspond to? That if I look at a point A, and so this is the point A, f of A on here. Or A, e to the A. Okay. Then also, if I'm going to look at the slope there, of this line, so this is the tangent line, and if I look at the slope there, the slope of this line is going to equal, so the slope is going to equal f prime evaluated at A, which is again e to the A. So that's the picture for e to the x. It's a great example. So the next one that I want to go through is the natural log. So we want to take, so that's my first example. I'm going to try to go through 4 examples here, so I might even draw a line here so that it's clear. There's the bottom of that example, and now I want to look at f of x equals the natural log of x. This is an important function to know because, among other reasons, so up here we were dealing with f of x equals e to the x. Now we're going to deal with f of x equals the natural log of x. So part of why that's an important function is the inverse function, right, of e to the x. Students always ask me, how do you understand the natural log of x? And I tell them I don't. I understand e to the x, and I work backwards from there. But what does the graph of this function look like? So let's put our axes. Okay, if I just switch the name on these axes, I would actually end up getting exactly that function, which is a way, if people haven't described inverse functions to you before, you can think of this as reflecting across the x equals y line. Then it's the way I'm going to figure out what the picture is going to look like. Or you could think, well, what if I swap my axes and I called this y and that x? Then this is what function I would get. That's another way to think of what it means to be inverse functions. So here's my x-axis, here's my y-axis, and then I'm going to go ahead and draw for you. Now, I'm instead going to be going through, so I want to go, I'm approaching this axis instead, and then going through here, and then I kind of arch more like this. It doesn't arch up, it arches down. Okay. And that would actually be at 1 again. So this is my graph of my function, just like this. This is the graph of this function, just like that was that graph of that function. And then I'm going to take, so if I look at a point A, well, I know here, so d dx is the derivative with respect to x of this one is, so the natural log of x is equal to 1 over x. And if I look at a point on here like I did there, and I look at the tangent line there, the one that just touches it, kind of approximates it close by, okay? If I look at this, so I'm going to get that this is, so the slope of this tangent line is going to equal f prime of a equals 1 over a, just like that's 1 over x, okay? So now, the next function that I want to look at, so those are two, and those are two related functions. Those are inverses of each other. And now I want to introduce ones that you may not have seen before. So these are going to be these trigonometric functions. So now I'm going to take the function, so I'm going to start with the function f of x equals sine of x. Okay, and I'll draw it for you in a minute, but I'm going to tell you first what its derivative is. So the derivative of this, so if I take d dx, the derivative with respect to x, as we get into dealing with multiple variables, it's good to keep track of that. So the derivative of sine of x is going to equal cosine of x, which is another function I'm going to draw for you in a moment. Okay. So here we go. So my axes, I was making green before, so let's do that again. So my x, my input-output axis, and y, my output axis. So the graph of the function, so when it goes to 0, it kind of looks like y, and then it goes like this. Okay, so that's the graph of this function here. And then I want to take, if I look at some point A, and I want to look at the slope there, I'll do A kind of over here, and I want to look at the slope here. So again, just like in these other circumstances, so I didn't kind of highlight it here, but I could. So this point here is A, f of A. It's good to emphasize these things because I feel like somehow they aren't emphasized enough in earlier classes and then students get confused. So this is A, f of A. I want to emphasize that. And then this is the tangent line. And so the slope, like in these other circumstances, so the slope here is going to equal f prime of A, right? Which in this circumstance from below, you know, is, or not below, by below I mean over there, you know, is cosine of A. Okay, perfect. Now, so that's the picture for sine of x. It's a really good function to know about. Now let's do the picture for cosine of x. I'm going to make this axis a little bit smaller for you. So that we can have more room for our other graph. So now the last one I want to show you here, so this is going to be f of x equals cosine of x. And I'll draw that for you in a minute. I first want to tell you, so it's almost the same as swapping, except for we pick up a minus sign when we have the cosine there. Okay, so if I take d dx, of cosine of x, I get minus sine of x. Sometimes we get sloppy and leave out those parentheses, but they end up being really useful if you have more than just an x in there. Okay. And now let's go ahead and draw this. And I can put this down. So I have again my input x axis and my output y axis. And then the graph of this function, instead it's going to look like, I'm going to go and then I'm going to go up and then down, up and down. Okay, so that's the graph of this function here, where y equals cosine of x. And then if I look at a point A, for example, well, we could actually make this quite boring. Let's for example put, well, okay, I'm going to make it boring and put a at 0. Who cares? Okay. So now if I look at the slope of this, that's a perfectly fine slope. It's just 0. Okay. So this point here is, again, this is a f of a. Good to keep track of these things. And then the slope of here, so the slope is going to equal f prime of a equals minus sine of a. Okay. So these were just a few derivatives that I wanted to give you that you may or may not have seen before. And also kind of that emphasize visualization of what's going on with these functions and the graphs of these functions and so on. But it's good to actually, these are 4 very important functions. These ones certainly, if you're in a business environment, are super important. These are very important in a physics environment and just in terms of understanding the world in general. Just kind of looking at these, you know that there are economic trends, for example, that are more sinusoidal, where things kind of, you hit the peaks and the troughs and the peaks and the troughs and so on. So these are important functions for a lot of reasons.